All right, this is Mr. Gillum, and today we're going to move on to lesson 4, and we're going to be solving problems with unit rate. The first problem says, Carrie Lee paints magnets that she sells at craft fairs. She can paint 12 magnets in 4 hours. At this rate, how many magnets can she paint in 2 hours, or in 10 hours? So the first thing that I notice about this problem, along with a lot of the problems in the Ready Math series, is that they ask two questions. They want to know how many magnets she can paint in 2 hours and in 10 hours. So we have two questions to answer. And so I'm not sure if the chart is in your book or not, but you can see that we have a chart comparing magnets to hours. And the information that was given in the problem is already matched up. Okay, 12 magnets in 4 hours. Magnets on top, hours on the bottom. 12 to 4. So there's a lot of ways that we can fill out this chart, and I'm sure that the book is going to lead us through these examples and kind of approach how to do these. But I always as always, to find the unit rate, and this is kind of what our main idea is centered around, is the unit rate. And so when I compare magnets to hours, 12 to 4, if I wanted to know how many magnets per 1 hour, I would need to find the unit rate. And I can do that by dividing both parts of the ratio by 4. 3 to 1. This is the related rate, and the unit rate is just the first number here, okay, when it's being compared to 1. But I know that 3 to 1 is the magnets in hours. I think I might already. Okay, so 3 can go there. And then I like these tables because there's a lot of different ways to fill in the rest of the values. We can count by threes, we can double numbers. There's a lot of things to do. I know that if the magnets are 3 and multiply that by 2, I can multiply 1 by 2 and I can figure out what number goes with 6. So in this case I know that 3 times 2 is 6, 1 times 2 would be 2. Okay. And then I can use kind of the same information to figure out what 8 is. In the same way, I know that 4 times 2 down here would be 8. So 12 times 2 would be 24. And now it's hard for me to multiply anything by 24 to get to 30. However, I do see that I have a column here that says 6 magnets and a column here that says 24 magnets. I know 6 plus 24 would be 30. And so I know that also 2 plus 8 would be 10. And so there's a lot of different ways to fill out the chart once you know one data point. And it doesn't have any of these other scenarios in there. That seemed to always be a question. Like, it doesn't have the numbers 3 and 1 in the problem, or 6 and 2 in the problem. But they are equivalent ratios. All the unit rates and the ratios are equivalent. If I reduce them down all the way down to the unit rate or the related rate, they would be the same related rate every time. Okay, 30 to 10 is the same as 3 to 1, and so on. So in this case it says, what is the ratio of magnets to hours? I'm assuming that probably wants us to answer with the ratio that's given to us in the problem. So I'm going to say that's 12 to 4. Okay, 12 to 4. Magnets first, hours second, and that is, the order does matter on that. What ratio do you get if you double the number of magnets in hours? Okay, so we already have done that. If we double or multiply it by 2, double means multiply by 2. If we multiply it by 2, we would get the ratio 24 to 8. Okay, and I did that in my chart, but also if I did 12 to 4 and I doubled it, it would be the same as multiplying by 2. So 24 to 8. How long would it take to paint 6 magnets? How do you know? Okay, so we've already kind of filled out this chart, but explaining how I know that it would be 2 magnets, 2 hours for 6 magnets. The way the book explains is because 6 is half the number of magnets. of 12 that she can paint in 4 hours. So one possible answer could be that if I'm moving from 12 to 6, I'm dividing by 2. So if I move from 4 down to the related ratio, I would also be dividing by 2. So that will give me 2. 6 to 2, so 2 hours, because 6 is half the number of 12, and 2 is half the number of 4. You do know how long it takes to paint 24 magnets and 6 magnets. How can you use that information to calculate how long it takes her to paint 30 magnets? So there's a lot of different ways we can do this. I think that I did it the same way earlier that the book is going to do here. I looked at the value of 6 and the value of 24. I added them together to get 30, like that. And so if I look at 2 and 8, I know if I add them together, I can get 10. So 30 to 10. And that's what this is explaining as well. It says to explain how you can use the information in the table to find out how many magnets you can paint in 1 hour. And so we initially did this with the unit rate. We started with our 24 to 8, no, our 12 to 4, and we divided both by 4, and we got 3 to 1. But if I were using the table, I could continue on dividing. Going backwards, I could say, okay, well, I see 2 divided by 2 would equal 1, so 6 divided by 2 would equal 3. And the unit rate is represented per 1, so per 1 hour, the unit rate in this case would be 3. So that's how they did this as well. They divided by 2 in both instances, and that showed that they had 1 hour for 3 magnets. 3 magnets in 1 hour. So you can see here that there's also a different way to represent the data using a double number line. It says a table is one way to show the relationship between the number of magnets and the time it takes to paint them. A double number line could also show the relationship. The main difference between the double number line and the table is the increments of magnets. So on our table, it was difficult to see if there was a pattern between on the magnets or the hours, because we didn't just increase the same amount each time. We did +6, we did +12, we did +6 again. So it kind of increased in different levels each time as we were looking at the magnets. And same way with the hours, we went from 1 to 2, from 2 to 4 is just +2, +4, +2 again. There was no specific pattern that was observable in the table. But if you look at the double number line, you'll see that it's spaced out evenly. Okay, it's drawn to scale. And so even though these are the same values, the 3 to 1, 6 to 2, 12 to 4, 21 to 7, and 30 to 10, those are the same values. Instead of squishing them all together in like a table, it's all spread out evenly. So there's room for gaps on the +3 pattern or the +1 pattern all the way through. It says, notice that the mark for 6 magnets is halfway between 0 and 12. And the line for 2 hours is halfway between 0 and 4 hours. You can use halves again to find the rate of 3 magnets in 1 hour. So if we were talking about trying to find the unit rate here, that it says, okay, well, if you look 12 and 0 between these two, halfway in between would be 6, and halfway between 0 and 4 would be 2. And then we could do the same deal here. Halfway between 0 and 6 would be 3, and halfway between 0 and 2 would be 1, and that we could find the unit rate in that way as well. You could use halves again to find the rate of 3 magnets in 1 hour. Once you know that the unit rate is 3, you can multiply or divide to find other equivalent ratios. So the unit rate is so important because now any of the numbers that I pick on here, even like 9, but like 9 here, I know that the number of magnets is 3 times that, so I know that could be 27. So the unit rate again is very important because it's a multiplier that you can find any other value if you have the hours or the magnets, depending on if you're multiplying or dividing. So it says to divide the number of magnets by 3 to find out how long Carolee will take to complete them. The number of magnets divided by the unit rate equals the hours. So Carolee will take 10 hours to paint 30 magnets. Multiply the number of hours by 3 to see how many magnets Carolee can paint in that frame. So the hours times the unit rate would equal the total magnets. So she could paint 21 magnets in 7 hours. So just all those words on there don't always make perfect sense, so I'm going to show you kind of what I mean. I know that 0, 3, 6, the next number would be 9 if I follow the +3 pattern. To find how many hours that would be, I could divide by 3 because there's a pattern here based on the unit rate that I always divide by 3 to find the number of hours it would take if I had the number of magnets. I know that would be 3. Okay, I could do the same thing with 15. I could divide by 3. I will get 5. Or 18. I could divide by 3 and get 6. And you can see that it's following the +1 pattern on the bottom. If I started with 8 or 9, I could do the same thing, but inversely. So instead of, because I had the hours this time, I could multiply by 3 to find the number of magnets. So the unit rate's important because it doesn't matter whether I have a known number of magnets or a known number of hours, I can still figure out the value that goes along with that corresponds with that. And so it says to explain and show how to use the unit rate to find the missing numbers on the double number line. That's kind of what I just walked you through there. Either I could multiply the number of hours by 3, or I could divide the number of magnets by 3 to find the number of hours. So, and that's all based on the unit rate. All right. So basically I had already filled this out, but I can do it again real quick. I see 24 here. If I divide that by 3, it would give me 8. And that follows the +1 pattern. If I started with 3 here, I would multiply by 3 to get 9, and that follows the +3 pattern. And it's all based on the unit rate per 1. Okay, that's it for today.